This lesson is on finding the area between curves. We're just going to do some examples. If you think about integrating just this top curve, y equals 2x squared, if we found the integral from -2 to 2 of y equals 2x squared, we would get all the area underneath the curve, all of this, between the curve and the x-axis. We're not trying to find that area, we're only trying to find the shaded area. So in order to find the area of the shaded region, you do the top curve minus the bottom curve. So you integrate from where they meet, so they meet at -2 and again at 2. So we're going to integrate from -2 to 2, and we're going to do the top curve. In this case, 2x squared is on the top the entire way, so it's 2x squared minus the bottom curve. Make sure you put it in parentheses because it's a binomial and you're going to have to distribute that negative. Now I'm not going to do all the integration. You should be able to do that, but I think you should pause the video right now and try it and make sure you get 128 over 15. This would be a no calculator question. So I'm just showing you how to set up the integrals. That's the only new stuff. This is good practice for you to actually integrate and plug in the numbers and see if you get the right answer. Okay, the next one. It's kind of the same idea. They meet at, well, they don't meet at -1, but it's showing you that they both, it looks like they might, they're asking you to integrate from -1 to 1. They're showing you that the region stops at -1 and 1. So even if the curves don't meet, they're giving you limits of integration. They only want to know what the area is from here to here. So you're going to integrate from -1 to 1. Your top curve is x squared. Your bottom curve is -2x to the 4th. So integrate that, and your answer should be 22 over 15 when you're done. This one's a little bit different because if I were to go from 0 to 2 and just do x minus x squared to the 4th, I would be including this area up here too, and we don't want that area. So what we're going to do is we're going to go from 0 to 1 of x minus x squared over 4. Then we're going to go from 1 to 2 of 1 minus x squared over 4. So you have two different curves here. So the integral from 0 to 1, the top curve is x, the bottom curve is x squared over 4. And we're going to add that to the area from 1 to 2. The top curve is 1, the bottom curve is x squared over 4. And when you do all of that integration, you should get 5/6. Okay. Now this time, there's no top and bottom. We're doing this curve from 0 to 1. That gives us this area. And then we're doing this curve from 1 to 2. So it's very basic. 0 to 1 of x squared. We're adding the two areas together from 1 to 2. The only problem is it's not solved for y. We need all of these functions to be functions of y in terms of x. So -x plus 2. And this one should be 5/6. Same as the other one. How about that? Okay, next. Now it gets a little bit tricky. This curve, 2x cubed, is like this. The curve -x squared plus 3x is like this. So from -2 to 0, the top curve is 2x cubed minus x squared minus 5x, and the bottom curve is -x squared plus 3x. But here, it changes, and the top curve becomes -x squared plus 3x, and the bottom curve becomes that one. So we have to do two separate integrals, from -2 to 0 of top 2x cubed minus x squared minus 5x minus bottom -x squared plus 3x plus the integral from 0 to 2. Now the top curve is -x squared plus 3x, and the bottom curve is 2x cubed minus x squared minus 5x. And when you do this one, your answer should be 16. Okay. Now we have three separate scenarios. When we go from -2 to 1, the top curve is the line and the bottom curve is the parabola. So we're going to go -2 to 1. The line is -x plus 2 minus the parabola, which is 4 minus x squared. Then the next section from here to here, so that's from -1 to 2, the top curve is 4 minus x squared, and the bottom curve is -x plus 2. And then finally from here to here, 2 to 3, the top curve is x again. I'm sorry, the line again. And the bottom curve is the parabola. This is a calculator question. You can actually plug these in. And you should have gotten 8 1/6 or 49/6. The one before this was a calculator question too. Okay, finally, the last type of problem you might encounter is one where it doesn't tell you what the x values are that you're integrating from, and you can't just guess. It does, however, tell you what the y values are. So we can integrate along the y-axis. Oh man, I forgot all this stuff. Every time you integrate, you need to have a dx, right? Because we're finding the area of all the rectangles. So these should all have dx's. That's my bad. Because it's telling you you're integrating with respect to x. Well, now we're going to integrate with respect to y. So our functions need to be in terms of functions of x in terms of y. So it has to say x equals. And you're going to integrate from 0 to 1. This time you're going to do the right-hand curve minus the left-hand curve. So it's almost as if you rotate the whole thing around and you go as if it were along the x-axis. So we're going to do right minus left. 12y squared minus 12y cubed minus 2y squared minus 2y. And that should, if you do that, you should get 4/3. Okay, so sometimes it happens where it's easier to integrate with respect to y. So you're basically just drawing rectangles up this way, and you're going to do the right-hand one minus the left-hand one. All right, I gave you a worksheet to complete as well. So try that.